Hello. So here is some double angle formulas or proofs of them. So the proof of cosine. This is cosine 2 theta is the same thing as cosine theta plus theta. So the cosine of the sum of two angles is going to be cosine of the first angle, cosine of the second angle, and then we will alternate the algebraic signs minus sine of the first angle times sine of the second angle. So this gives us cosine squared theta minus sine squared theta is equal to cosine of 2 theta. But also we know that cosine squared is equal to 1 minus sine squared, so this is the same thing as which is so here is one identity for cosine 2 theta. Here is another identity for cosine 2 theta. And if we have cosine 2 theta is equal to sine squared theta is 1 minus cosine squared. So we have because these two are the same, sine squared theta is equal to 1 minus cosine squared theta, and cosine squared theta is equal to 1 minus sine squared theta. This is because the fundamental identity in trigonometry is cosine squared theta plus sine squared theta equals 1. Okay, so this is, when you distribute the negative, we have we get the same thing with the proof of sine. Sine 2 theta this is going to be sine of the first angle times cosine of the second angle, and then change their algebraic signs. I'm sorry, we keep the same algebraic signs. We have cosine of the first angle, sine of the second angle, sine theta cosine theta plus sine theta cosine theta. We have two of them. Now for your double angle formulas, we can take any one of these. I'm sorry, the half angles we can take any. So with the double angle formulas, sine 2 theta is 2 sine theta cosine theta. Cosine 2 theta is all three of these. Cosine squared minus sine squared, 2 cosine squared minus 1, and 1 minus 2 sine squared. And then for the tangent 2 theta is 2 tangent theta divided by 1 minus their product. So a proof for the half angle formula. So note that one form of cosine 2 theta is 1 minus 2 sine squared theta. Sorry, cosine 2 alpha is equal to 1 minus 2 sine squared alpha. Okay, so this is the same thing. We can add 2 sine squared alpha to both sides. And we have and then we can subtract cosine 2 alpha from both sides. We can divide both sides by 2. And then we take the square root of both sides. Since this is good for any angle alpha, and since this alpha angle size is twice as big as this alpha angle size, this is definitely a true statement. But also, this is a true statement. So long as this angle is half as big as this angle, we are fine. Now this plus or minus depends upon what quadrant you are in. Remember, sine is positive in quadrants 1 and 2, negative in quadrants 3 and 4. And then without loss of generality, here are the other half angle formulas. Cosine alpha over 2 is plus or minus 1 plus cosine alpha over 2. The only difference between sine and cosine is that negative value. Tangent, since tangent is sine over cosine, we can divide one over the other. But also, so these are also both. Let me show you one of them, 8. It's real simple. Proof of 8. So tangent alpha over 2 is equal to sine alpha over 2 divided by cosine alpha over 2. Sine alpha over 2 is sinus minus. When you are dividing radicals with the same index, you can combine the radicals. The same 2 denominator on both of these will give us and that is one of the tangent alpha over 2's. But let me show you how the book got to these two. Here we have a difference of squares. This denominator, 1 minus cosine squared, is sine squared. The square root of sine squared is sine. And if I were to times this by 1 plus cosine over 1 plus cosine, then the denominator is 1 plus cosine. The numerator would be sine squared, which is where we get this at. Thank you very much. Please go to tutoring.